Interactive algorithm tutorials online. Master complex concepts through engagement in today's rapidly evolving tech landscape. Mastering algorithms isn't just about memorizing formulas, it's about understanding patterns, logic, and problem-solving strategies. For developers, students, and enthusiasts on the Algohay platform, accessing high-quality algorithm tutorials is crucial. However, traditional static guides often fail to engage learners deeply, leaving gaps in comprehension. This article explores the world of interactive algorithm tutorials designed specifically for programmers seeking practical mastery. We'll uncover how these dynamic resources bridge theory and practice, offer structured learning paths, and leverage technology to enhance understanding. Whether you're preparing for coding interviews, advancing your technical skills, or exploring new domains like machine learning, this guide provides actionable insights to elevate your learning journey. The power of interactive learning in algorithm education. Traditional textbooks and lecture-based approaches to algorithm education often leave learners struggling to grasp abstract concepts. Static diagrams, dense prose, and passive reading don't always translate well to real-world application. This gap has fueled the rise of interactive algorithm tutorials, which transform passive consumption into active participation. These tutorials incorporate visualizations, simulations, and real-time feedback mechanisms. By allowing learners to manipulate variables, trace execution steps, and see outcomes instantly, they demystify even the most complex topics. For example, sorting algorithms become tangible when users can drag and drop elements to observe how quicksort partitions arrays step by step. Why does interactivity matter? Cognitive science shows that engagement improves memory retention. When learners interact with material rather than merely read it, neural pathways form stronger associations. Platforms like Algohay recognize this principle, embedding interactive elements into their tutorial frameworks to maximize comprehension. Dynamic visualizations. See binary trees grow node by node or track time complexity with animated graphs. Real-time debugging. Practice fixing errors in pseudocode with instant validation against expected outputs. Adaptive challenges. Receive personalized exercises that adjust difficulty based on performance metrics. By integrating gamification elements such as progress tracking, badges, and leaderboards, these tutorials sustain motivation over long study periods. Learners aren't just absorbing information, they're building muscle memory for problem solving. Beyond code, understanding algorithm design principles. Algorithm tutorials go far beyond syntax instruction. At their core, they teach fundamental design principles that define efficient solutions. Topics range from asymptotic analysis to greedy versus dynamic programming paradigms, all explained through interactive exploration. Take divide and conquer algorithms, for instance. A static description might mention splitting problems recursively, but an interactive tutorial allows users to visualize merge-sort splitting arrays until base cases are reached. Users can then reassemble the sorted segments, witnessing firsthand how recursion reduces complexity. Decoding time complexity through simulation. Time complexity remains one of the trickiest concepts for beginners. Traditional explanations rely heavily on big O notation, which can feel abstract without context. Interactive tutorials tackle this by letting users input custom datasets and watch runtime comparisons unfold. A common exercise involves comparing linear search versus binary search on varying array sizes. As users increase the number of elements, animations show exponential differences in operations performed. This hands-on approach makes theoretical trade-offs intuitive, reinforcing why certain algorithms scale better than others. Data structures like hash tables benefit similarly. Interactive modules allow learners to insert keys, collide, and resolve conflicts visually. Seeing hash functions map inputs to buckets helps explain why collision resolution strategies matter for performance optimization. Hands-on practice. From theory to implementation. Mastery of algorithms hinges not just on conceptual clarity but also on implementation proficiency. Top-tier tutorials provide coding environments embedded directly within lessons, enabling immediate experimentation with languages like Python, Java, or C++. Learners can write and test snippets inline, receiving live error messages and suggestions for improvement. For example, when studying graph traversal algorithms, users can implement BFS or DFS in real time, observing pathfinding behavior on dynamically generated grids. Key advantages of integrated coding: rapid iteration. Debugging becomes faster with built-in editors, eliminating setup overhead. Instant feedback. Compare your solution's output against reference implementations side by side. Version control. Save progress across sessions to revisit unfinished exercises later. Some advanced platforms even simulate interview scenarios, challenging learners to solve leak code-style problems under timed conditions. These drills mimic real-world pressures, helping build both speed and accuracy. Navigating advanced topics. Machine learning and cryptography. While foundational algorithms form the bedrock of computer science, modern applications demand deeper specialization. Interactive tutorials now cover niche areas like machine learning models, cryptographic protocols, and distributed systems, all made accessible through guided walkthroughs. Machine learning tutorials, for example, let users train decision trees or neural networks by adjusting hyperparameters in real time. Watching loss curves update as regularization strengths change illustrates trade-offs between model complexity and generalization capabilities. Cryptography made tangible. Cryptographic algorithms, once opaque due to mathematical complexity, gain clarity through visualization. An interactive RSA encryption module might walk users through prime factorization, modular arithmetic, and public-private key generation step by step. Users can experiment with small primes to see how security degrades as key size decreases. Animations reveal vulnerabilities in weak ciphers, making abstract concepts like padding Oracle attacks comprehensible through concrete demonstrations. Blockchain tutorials take similar approaches, simulating consensus mechanisms like proof of work. Learners witness miners competing to validate blocks, understand hashing functions' role in immutability, and see forks emerge during network splits, a process rarely grasped from textual descriptions alone. Community collaboration, peer review and shared projects. Many algorithm tutorial platforms foster collaborative learning environments. Features like peer review, shared whiteboards, and version-controlled repositories encourage collective problem-solving and knowledge sharing. On Algohay, learners can join virtual study groups to dissect tricky problems together. Real-time collaboration tools enable teams to sketch out algorithm designs, critique each other's approaches, and refine solutions iteratively, an experience mirroring professional software development workflows. Benefits of collaborative learning include diverse perspectives. Exposure to alternative problem-solving methodologies expands cognitive flexibility. Constructive criticism, receiving feedback sharpens analytical thinking and attention to edge cases. Shared resources, access curated libraries of optimized code samples and benchmarked implementations. Platforms may integrate social features like discussion forums, Q&A threads, and mentorship programs connecting novices with experienced developers. These interactions help contextualize theoretical knowledge within industry standards and best practices. Personalized learning paths, adapting to your skill level. No two learners follow identical trajectories. Effective algorithm tutorials adapt to individual pacing, prior knowledge, and goal orientations, from beginner introductions to expert-level optimizations. Smart platforms employ adaptive learning technologies that assess quiz results, coding performance, and interaction patterns to tailor recommendations. If a learner excels at tree traversals but struggles with dynamic programming, the system might suggest targeted drills focusing on overlapping subproblems and memoization techniques. Customizable learning journeys typically include skill assessments. Initial evaluations determine baseline competencies and identify knowledge gaps. Progress tracking, dashboards display completed modules, time spent, and mastery percentages per topic. Goal setting, define objectives like acing coding interviews or mastering parallel computing fundamentals. Such personalization ensures learners spend time on challenging areas without getting bogged down by redundant basics. It also prevents frustration by aligning difficulty levels with current abilities. Evaluating tutorial quality. What makes a great resource? With numerous algorithm tutorials available online, discerning quality is vital. High-performing resources exhibit clear pedagogical structure, accurate technical depth, and robust interactive components. Red flags to watch for include overwhelming information density. Avoid tutorials that cram too much content without explaining prerequisites. Lack of practical examples. Beware of purely theoretical treatments devoid of coding exercises. Poor technical accuracy. Verify claims about algorithm efficiency match established computational complexity theories. Reputable platforms often feature instructor credentials, peer reviews, and endorsements from recognized institutions. Cross-referencing multiple sources can help verify consistency in explanations, especially for contentious topics like amortized analysis or NP-hardness proofs. Algohay members should prioritize tutorials that emphasize problem-solving heuristics alongside rote memorization. The ability to apply concepts creatively, such as adapting Dijkstra's algorithm for route optimization in non-grid topologies, is increasingly valued in technical roles. Future trends. AI-powered tutoring and virtual reality simulations. The evolution of algorithm education continues accelerating with emerging technologies. Artificial intelligence is already transforming tutorials through intelligent assistants that answer questions in natural language and auto-generate practice problems based on learner profiles. Virtual reality, VR, promises immersive experiences where users physically navigate algorithmic processes. Imagine stepping into a 3D representation of a linked list, manipulating nodes with hand gestures, or visualizing matrix multiplications in spatial dimensions. While still nascent, early prototypes demonstrate immense potential for deepening conceptual understanding. Augmented reality, AR, applications could overlay algorithm visualizations directly onto physical objects. For instance, projecting a binary heap onto a desk surface enables tactile exploration of insertion/deletion mechanics through gesture controls. Such innovations blur boundaries between digital abstractions and physical intuition. As these technologies mature, expect hybrid learning ecosystems combining AI tutors, VR/AR interfaces, and blockchain-based certification systems. Learners will gain verifiable credentials attesting to skill mastery, opening doors to career advancement opportunities globally. Conclusion. Interactive algorithm tutorials represent a paradigm shift in educational methodology. By merging cognitive science principles with cutting-edge technology, they transform abstract mathematical concepts into tangible, experiential learning opportunities. From dynamic visualizations to collaborative problem-solving spaces, these resources empower learners to achieve profound mastery. To thrive in the ever-evolving field of computer science, embrace platforms that prioritize interactivity, personalization, and practical application. Explore Algohay's extensive library of algorithm tutorials, participate actively in discussions, and continually challenge yourself with advanced projects. Remember, the most powerful algorithms aren't just written in code, they're forged in the minds of relentless learners.